Hello and welcome to our video on perpendicular and parallel lines. Now you will remember that the general equation of a straight line looks like this: y equals mx plus c, where the m is the gradient and the c is the y-intercept. So if we look at two straight lines with equations y equals mx plus c, and all I've done is for the m I've put an m1 and a c1 to say it's the first equation, and y equals mx plus c with a 2 to say it's the second equation. If m1 times m2 equals negative 1, and that's the most important line here, then the lines are perpendicular, which means at right angles to each other. So they cross over at right angles when you graph them. Also keep in mind, if m1 and m2 are exactly the same, so the two gradients are the same, then the lines will be parallel. Okay, there are 4 examples down here that you might like to pause the video and have a go at doing yourself. Pause the video now. Okay, let's look at the first example. Write down the gradient of a line which is perpendicular to a line with gradient 4. So we know m1 is equal to 4. We can write down our equation. m2 equals negative 1 over m1, and that's just a rearrangement of this equation here. So you might like to jot that one down too. m2 equals negative 1 over m1. All I've done is taken this m2 over the other side and divided by it. So you can use either of these two equations to find perpendicular lines. So we've got m1, we can substitute that in negative 1 over 4, and that's your gradient. Done. m2. Write down the gradient of a line which is perpendicular to this line. So the gradient of this line is negative 2/3. m2 equals negative 1 over m1 equals negative 1 over negative 2/3. And when we have a fraction in the denominator, we can flip it. These two negatives are going to cancel out. So it will be 3 over 2, positive 3 over 2 for the second gradient. Last one, find the gradient of a line perpendicular to this line. Now this one's not in y equals mx plus c form, so we need to rearrange. Let's see, negative 4y equals 2, take 3x. Y equals 2 on negative 4 minus 3 on negative 4x, which is going to equal negative 1/2 plus 3/4 x. So our gradient of this equation is 3/4. Our equation is m2 is negative 1 over m1. Negative 1 over 3/4. We've got a fraction in the denominator again, so we can just flip it. It's going to be negative 4 over 3. And that's your final answer. Okay, third example. This one's a bit more involved. The coordinates of the vertices are the corners of a triangle ABC, are this, this and this. Show that one side is perpendicular to the other side. So for me, before I start working with this, I really need to see this visually. So I'm going to draw up a quick sketch. And we've got A is 0, -1. B is at 2, 3. And C is at 3, -2. Two and a half. Okay, useful to label them all. Show that the side AB, so that's this one here, is perpendicular to AC. So we want to show that this is a right angle. And my diagram drawing was pretty good because it does look like it is a right angle. When you have show that questions, you need to make sure you work through right from the start and that your final line shows that they are perpendicular. Basically, they're giving you the answer, but you need to show all the working to get there. So it would be the same as the same question as, is AB parallel to AC? And you would show the exact same working for that question. Oh, sorry, not parallel. Is AB perpendicular to AC? So to find out if they are perpendicular, we're going to have to find the gradient of this line, AB, and then the gradient of AC. So I'm going to say, not with a highlighter, AB gradient I will call M1, and AC gradient I will call M2. To find the gradient of a line between 2 points, we use y2 minus y1 over x2 minus x1, which equals, if I make this y2, actually I better write it out, 2, 3, 0, -1, x1, y1, x2, y2. So we get -1 take 3 over 0 take 2, which equals -4 on 2, which is -2. Hang on, -4 on -2, +2. That's our gradient of AB, 2. I will do AC in green. Need to write out so it's AC, need to write out these two coordinates. X1, Y1, X2, Y2. -2.5 take Y1, which is -1, so we'll make that +1. Over x2, 3 take 0. -1.5 over 3. Okay, you can see that's over 3. I'm not sure why it's going all blurred. And that equals -1/2. So this is M2, this one here is M1, and we need to show that AB is perpendicular to AC. So if they're perpendicular, M2 times M1 will equal -1. M2 is -1/2, M1 is 2. It does equal -1, therefore AB and AC are perpendicular. Sorry about the blurring there, not sure what's going on with the computer. Thanks for watching the video.